Cool. So this is our reading group about rugs meeting knowledge bases, which is a rather hot topic lately. There have been a couple of publications that sort of have married the two, and we've seen some applications that seem to be using similar approaches. Hence, I thought it would be a good idea to touch on this topic here, because I think it's quite applicable to the work we do. So as usually, I'm going to start with some caveats, because it's worth saying that, as always, I'm not an expert and I have, limited time to prepare for these things. And it's, a complex topic as well. So I'm oversimplifying and I'm not covering every detail. I am linking, though, to papers with details, which I've read, and you can read after. So I'm going to share the slides and the recording will be up as well. So with that said, and it might be a small presentation anyway, I want to start by setting up the problem. RAG is great, and we've been using RAG with a couple of clients, and there have been numerous applications of RAG, but it comes with some limitations that you might or might not be aware. First and most obvious is the fact that the world is changing. So even if you're updating the knowledge that is incorporated into your RAG system, that doesn't take away from the fact that invalidated but relevant knowledge might be retrieved and confuse the answer when you're actually generating it. So that's problem number one. Then there are questions that rely on a couple of documents that sort of contain different information and that are not similarly relevant. So it's quite hard sometimes to optimize for retrieving all those pieces that are different at the top of your context. But more so, it's more difficult if you need to do intermediate reasoning. So not so much necessarily retrieving all those disparate information, but basically retrieving one, doing a little bit of a reasoning for this, and using that new piece of information to go to the extra step, so-called multi-hop reasoning. So those things are quite hard for naive RAG implementation. And on top of that, as well, when you're generating an answer, it's a little bit of a black box. You have knowledge because you retrieve information from a retriever, so you can re-rank them or change the facts there. You have a little bit of control on your prompt, on the type of model you use. But at the end of the day, when these limitations hit, for example, the context being invalid or wrong, or the question needing some sort of intermediate reasoning or information it doesn't have, the generation of the answer is a little bit out of your control in some ways. You don't have a complete control over that. So the answer might still not be appropriate or wrong. Now, you might think, that's fine, we can fine tune the whatever LLM we're using into the new knowledge we have. If in particular, this is an applied project for a particular company, you have a specific set of questions, you might want to use an LLM, and you might want to start incorporating the knowledge of your company, of whatever custom data you have, into the LLM. Unfortunately, though, we've seen that doing so overfits quite quickly. It seems like LLMs are quite good at learning the information they already know if you're giving to them things that are not very far away from the training data they were trained on. Not so good at incorporating that new information. They can do that, but at the expense of forgetting some of the initial knowledge, which you might want to keep for the application to perform where you want. Also, you can think that you might be able to address this issue with some sort of editing of the LLM knowledge while preserving the things it already knows. So there is a long literature on that. And simplistically thinking, you can create a loss with a sample of the previous knowledge or even the original data set, and the kind of new information you can incorporate and instruct and learn either tune the existing model without loss or learn a model that edits the knowledge pieces within that LLM, similar in some ways to what we saw in the other reading group about interpretability, in the way that you're trying to find out what you need to change in the network in order to edit its current knowledge while leaving everything else stay the same. Unfortunately, though, as well, this has been shown to not perform very well, not much better than what you had previously before editing the knowledge. So this approach, even though it seems like it could also solve the problem, in practice, it's not many times. So let's look, this is the motivation of the problem that we have at hand. And these are some ways you can address that problem by marrying RAG with knowledge bases. The very first thing you can do, and very obvious, is instead of relying on the documents themselves as they are, splitting them into chunks and embedding them to retrieve them, you can instead extract facts from the text that would be useful come answer time to give appropriate answers. This reduces the noise first. Also, it gives you an ability to go into those facts and interrogate them. It also gives you the ability to improve the fact extraction process that sort of that comes before you start retrieving. So this is one. Of course, this comes with a limitation that you might still keep irrelevant information in, so you can take that a step further. And you can not only extract, simple facts, you can actually extract, first of all, facts or entities and relationships. You can actually go and construct a knowledge base out of your documents. And more importantly, you can take that a step further. And every time you have a new information in, you can edit this information in the knowledge base. For example, a new information might come in that reinforces what exists in the knowledge base. This adds further support there, doesn't change the fact or a new information might come in that invalidates a fact that lives in the knowledge base. You can update that information you can do nothing if the information that comes is sort of irrelevant. And of course, every new information that comes in, you're going to be doing the same process again, right? So you're going to be extracting entities and relationships, and you're going to be updating the knowledge base. The idea essentially of, this is that you're trying to maintain, a structured way and knowledge of your information. And you're trying to keep that up to date so that to use it come retrieval time, one way or the other, to give correct answers. You can take that one step further, and instead of just simply retrieving from an up-to-date knowledge base in a sort of similar to the naive approach, but at least with a knowledge base that is structured and contains up-to-date information, you can actually use the graph itself to retrieve. For example, similar to what we were describing before, you can extract the entities and the relationship. You can construct a knowledge graph out of all of those things. But then come retrieval time, you can do the same process. You can extract the key entities and facts, and then you can use those to query your graph, essentially trying to find those nodes or entities in the graph you've created in your knowledge base, and search for information around where they live to incorporate it into the context of that you provide to the LLM for answering. Or you could even simply try to answer using all the information of the entities and the relevant information in an even more deterministic way, not generative way even. But in any case, it was saying that this approach resembles somewhat what is happening in the brain. So there's a little bit of motivation there. It's not very different from what we showed before, but it's just taking what we showed before a step further. Now, not gonna tell you how well that approach works, the previous one that sort of mimics the brain, but I think this communicates very well the difference that we're trying to see here. So the naive rag is the blue line. You can actually use nowadays models that sort of can contain multiple documents entirely into their context, as we know, and this is the red line. This underperforms for a couple of reasons that we've seen in other papers. One of which could be the lost in the middle effect, but there are many more reasons why it's not able to use all the information it has in the context effectively. The orange line is just extracting the facts essentially, and the green line is this approach that we saw second, which was to not only extract the facts, the relationships, but also edit them as they come in. And the x-axis is date, because as we said, one of the things that can go wrong is as information changes, then some of those approaches are not able to keep up. And this demonstrates that this approach is somewhat more robust into a world that is changing.
I had a question about the graph, if that's okay.
Yeah.
If you could just go back to the graph for a sec.
Yeah.
One forward, sorry. The comparing RAG approaches. Yeah.
Yeah.
So with the later dates, is that in the full context also giving it older documents? So you might get documents from, say, before Queen Elizabeth died and documents after, whereas the RAG ones are likely to just get the new documents.
In the right one, so yes, I think is the answer. We can go and double check. Of course, I'm assuming that they come with the information of the date in the case of the full context, but even so, like it doesn't help them resolve it.
Yeah, the model needs to care about the date.
In the case of the facts, I think similarly they can. The older ones still come and are retrieved, even though there are newer information. It's just that the facts alone do a better job at being able to reason that this is the latest fact from what it seems. And I think only in the green case is where the information that sort of predates and is invalidated is not incorporated into the context.
This is something I haven't understood in the approach generally. So we do update our knowledge base, right? So do we keep the original documents separate from the knowledge base artifacts, or do we directly edit the documents that we retrieve? Like taking Queen Elizabeth as an example, right? So we do have a lot of documents stating Queen Elizabeth, and then towards the end-ish, we do have an article that says that she died. So now we would expect this to update our knowledge base, right? But do we, like how is the knowledge base actually stored vis-a-vis the original documents, like the older documents? Do we modify older documents, or do we do it separately? Like where do we store that updated information?
The details of this is that it actually keeps a track of the versions that happen. But remember, we're not storing documents per se, right? We're splitting the document into chunks of information, and then what happens is each of either the entities or the chunks essentially are retrieved come time to update the information. So you retrieve all the relevant pieces of the query, and then you either update them, rewrite them, leave them as is. So basically, you end up with a new state of the knowledge base.
Okay, all right.
That contains an up-to-date information. You do have the older trace as well, but that trace is not, being used.
Okay, so we don't touch the original documents, but we do touch those extracted snippets of information that is in our knowledge base.
Yeah.
Okay, right.
Yeah, okay. Exactly, and we keep a track of the changes.
And then during inference, like we consolidate these rewritten facts. Okay, right. That makes sense. Thank you.
So if I'm understanding this right, is it the knowledge base isn't a temporal one as such? It only has like a snapshot of a single point in time. It's not saying in 2018 this was true, in 2019 this was true, and so on and so forth. where you kind of layer up the different time frames.
It has information of the time, but I think it's irrelevant of the point. I guess the point I'm trying to take from the paper is that we can, start with a set of documents. We can split them and extract entities, relationships, create a knowledge base out of this. And then we can keep the knowledge base up to date as new information comes in. In the particular paper, they do contain a history of all the changes, which, I don't necessarily think you always have to do. And they do keep a timestamp as well.
Yeah.
I think the point I want to sort of leave us with is that you can do that creation step and update step in order to always have, like a knowledge base up to date you can use for generating answers.
And we do have this binary true-false label for the facts that we have in our knowledge base, which get assigned during the offline indexing step, I assume.
Yeah, in this paper, this is how they're doing it. It could be that we're basically throwing away everything that is false, and whatever is in the knowledge base could be true. Like this is an implementation detail that is our choice.
Okay.
Makes sense.
Yeah, makes sense. Thank you.
Cool.
Cool. So 2 more slides, basically. I wanted to say kind of what we were discussing here. Like there are some benefits I'm seeing to this approach. That's why I think it's sort of becoming more popular, which is the fact that it is a modular approach, which is something we like. So you have a component that you sort of extract the facts or the entities, the relationship, and you can interrogate that component and improve it independently. You have another component that updates that information. You have another component that sort of generates the answers or searches the graph in a sort of graph way before creating the answer. It's a very modular approach that you can improve iteratively, independently. It's also quite debuggable. Instead of just retrieving documents and then generating answers, you can sort of interrogate which piece of the puzzle doesn't work and fix it as well. And it's more explainable. You can sort of follow the trace of what's happening instead of simply retrieving some things and relying on embeddings, and is the only thing that explains the semantic similarity between the documents. And then on the other part, on the generation, the only thing that explains the generation is the generation, network essentially, plus the context. So it offers a lot of benefits, I think, for applied applications. And I think part of this is what we're seeing with Apple Intelligence. Now, we don't know for sure, but the way they have talked about this rings a lot of bells similar to the things we were describing. Taking all the information from your phone, storing it into some sort of knowledge base. All of these things are different, and creating relations out of them, and then being able to use that knowledge base either in a graph way or a retrieval way. I'm thinking more in a graph way to retrieve all the relevant information to answer questions. And I think the examples they gave when they introduced the feature speaks a little bit to those use cases and to that way of thinking somewhat. It's not always the case, because there are use cases of Apple Intelligence that are summarization, rewriting, and so on and so forth. But when it relates on taking all the data you have from applications, connecting them together and being able to query them, saying things like find, like which location was when I last took this photo there and send a message. This is a thing where the approach we were describing must be applied if they are. Any questions?
No. I think this is super interesting. I'm a big fan of these external knowledge and knowledge emphasized approaches. I do think it's interesting to flag things as true or false. I mean, it's like I guess it connects to how you separate things into facts or snippets. Would be interesting to investigate it further. And I was surprised that the improvement over base level reg is not that much. That's a bit underwhelming.
Yeah.
I don't know how difficult that benchmark is, but I would have expected more of an improvement.
Yeah. It is an interesting concept. Compared to baseline RAG, they do also mention it's arguably more efficient, so that's one way they can say they've improved.
Right. Okay.
But you can also argue it's less efficient because there's a lot more processing.
Mm,
The limitations of the paper is quite interesting. One thing they do notice that I flagged up from the diagram is the LLMs are directly editing that knowledge based on what they think has become true or become false and so on. And that can, of course, introduce noise and hallucinations. And I would definitely be a bit skeptical of that part in a production system. Yeah, certainly I'd want kind of human validation there as well. But it's certainly an interesting concept.
Yeah. No, I mean the performance. First of all, I think varies. Like in the graph I shared, it does seem to be minimal, and I think that's partly the reason why like this is still an active area. It's not sort of the de facto way of doing things. But in other cases, like it seems to work a little bit better. So we're still sort of in a place to wait and see. I think the argument that is a little bit more of a deterministic approach and maybe more applicable, and that like we have more control over. I think that is a little bit stronger, even if the improvement is lower. It does give you more controls than you have if you're going end to end with a two-step approach, for example.
yeah, for sure.
Yeah, it's interesting looking at the paper. They compare the different approaches between Mixtral and Llama. And then if you don't mind me showing my screen quickly, just show that.
Go for it.
Screen sharing slightly buggy on mine for whatever reason. Sorry, 1 second. I'm gonna sorry about that. Gonna try and fix screen sharing. That does not seem to be working. If you go to this link and you go to like page 7, you can see the two graphs side by side. Sorry, I don't know why it's not letting me screen share.
I'll share this. Don't worry. I intentionally did not include the other graph. This graph, right?
Yeah, it's interesting that there's a decently large margin between full context and any of the other RAG methods, but they're actually all pretty similar to each other. I think even more so for Llama than for Mixtral. It's quite an interesting difference to me.
Yeah. In Mixtral, there is a 10% difference from 0.6 to 0.7. In the case of Llama, this is a little bit of a narrower gap.
Yeah, like 0.06 also.
But yeah, 100%, as we said, it's not a silver bullet for sure.
Yeah, Llama might just be better at filtering out the noise, perhaps. So there's less need for kind of the really good RAG to mitigate it. Interesting your clarity on
more work to sort of do these comparisons, just to have like a final say. Like all of these things are first passes and exploratory and have their own limitations.
Yeah.
But like if you compare for more time frames or for more complex use cases that do like have more noise inside and require multiple steps to answer or are closer to what people are doing in practice, maybe the difference in all of those things will be larger than what we're seeing.
Yeah.
Okay, that was nice.
Yeah,
We're on
that was
time.
interesting. Thank you.
Yeah, thanks for presenting that, Nick.
Very good. I'll see you at the next one.
See you
Yeah.
then.
See you.
All right.
Bye-bye.
Have a nice day, guys. Bye.